buoyancy. What is this buoyancy? So you have learned it in your lower classes as well, children. Have you ever had a swim in a pool and felt lighter? Have you ever drawn water from a well and felt that the bucket of water is heavier when it is out of the water? Have you ever wondered why a ship made of iron and steel does not sink in sea water while the same amount of iron and steel in the form of a steel would sink? These questions can be answered by taking buoyancy in consideration. Let us understand the meaning of buoyancy by doing an activity. This is very interesting activity, children. All of you might have experienced it. See, when you are when you are drawing the water from the well, you may feel that the bucket is heavier when it is out of the water. Similarly, have you ever wondered why the heavy ships which is going in the sea doesn't sink? Why all this may take place under this concept of buoyancy comes into play. What is this buoyancy? We shall understand with the help of an activity. As they said, it is very interesting activity. What they have said is, take an empty plastic bottle, close the mouth of the bottle with an airtight stopper. Put it in the bucket filled with water. So put it in the bucket filled with water. You see that the water floats. Push the bottle into the water. You feel an upward push. Try to push it further down. You will find it difficult to push deeper and deeper. This indicates that water exerts a force on the bottle in the upward direction. The upward force exerted by the water goes on increasing as the bottle is pushed deeper till it is completely immersed. Now release the bottle. It bounces back to the surface. Does the force due to the gravitational attraction of the earth acts on this bottle? If so, why doesn't the bottle stay immersed in water after it is released? How can you immerse the bottle in the water is the question. So the force due to gravitational attraction on the earth acts on the bottle in the downward direction. So the bottle is pulled downwards. But the water exerts an upward force on the bottle. Thus the bottle is pushed upwards. They have learned that the weight of an object is the force due to gravitational attraction of the earth. When the bottle is immersed, the upward force exerted by the water on the bottle is greater than the weight. So it is a very simple activity. You need not take a bottle filled with water. Any object you take for that, children, if you try to push it inside the water, it is very difficult to push. The water is exerting the backward force upon that object. As you are trying to push it deeper and deeper to the bottom of the bucket, the water in turn pushes it upwards. Suddenly, if you remove the force or release the force which you are applying on the object, it will come with a great force to the top. And it will not come hit your face, instead it floats on the surface of water. So the question is, don't you think the acceleration due to gravity is acting on it? Yes, of course it is acting, but the gravitational force of earth is pulling the object down, whereas the water force's pressure is pushing the object in the upward direction. So the upward force exerted by the water on the bottle is greater than its weight. Therefore, it rises up when released. To keep the bottle completely immersed, the upward force on the bottle due to water must be balanced. This can be achieved by externally applied force acting downwards. This force must at least be equal to the difference between the upward force and the weight of the bottle. The upward force exerted by the water on the bottle is known as upthrust or the buoyant force. In fact, all the objects experiences a force of buoyancy when they are immersed in a fluid. The magnitude of this buoyant force depends on the density of the fluid. So, of course, how would you balance the bottle there? Means it's completely the weight of the force is more. The force is more compared to the weight of the bottle there. So, to keep the bottle completely immersed, the upward force due to water must be balanced. This is very important. So how can this be achieved? Means by applying the external force. Means you have to hold it firmly there without releasing, then only the balance can be achieved. So the force must be equal to the difference between the upward force and weight of the bottle. So the upward force exerted by the water, we studied that when you are trying to immerse the water will push the bottle upward. The upward force or the thrust, pressure it is called, children. With what it is pushing up is nothing but the force there is called the buoyant force. It is called the buoyant force, and experience a force of buoyancy that tell when you try to insert or immerse any object inside the fluid. Whenever you try to, so what is buoyancy? In order to conclude with one statement, whenever you are trying to immerse any object inside the water, children, you are applying the force in order to immerse it, but the water in turn applies the upward force or thrust on the object, and the object comes up. So this force is called the force of buoyancy or the buoyant force. So next we should know why the objects float or sink when placed on the surface of water. This is very much simple what you have been learning from the lower class. So if the density of the object is more, if the mass of the object is more than that of the water, then it will sink. If the mass is less, then it will float. That is the reason. So here they have given an activity. The nail sinks. The force due to the gravitation attraction on the nail pulls it downwards. There is an upward thrust on the water on the nail which pushes it upwards. But the downward force acting on the nail is greater than the upthrust on the nail. So few objects, if you are telling it in terms of buoyancy, children, if the weight is more, then of course it will push. If the weight is less, means here they tell no, the upthrust of water on the nail which pushes it upwards, but the downward force acting on the nail is greater than the downward force acting on the nail is greater than the upthrust of water on the nail. So it sinks. There is an upward thrust on water on the nail which pushes it, but the downward force acting on the nail is greater than the upthrust of the water. So in case of the nail, if the objects are floating on the surface of water, then we can say that the upward force exerted by the water on the object is less compared to the weight of the object. Hence it floats. But if it is more, then it sinks. Similarly, they have given the cork floats while the nail sinks. This happens because of difference in their densities. The density of a substance is defined as the mass per unit volume. So density is defined as the mass by volume. Density is mass divided by volume of the object. How heavy it is, what is its mass, and how much space it is occupying. That ratio, if you take, what you get is density, children. So here they are using the concept of density. The density of object is defined as mass per volume. The density of the cork is less than the density of water. I said no, if the density of the object is less when compared to density of water, it will float. If the density of the object is more than the density of water, then it will sink down. That is the reason why few float and why few objects sink. Next you have very important principle, that is the Archimedes Principle. Concept of this buoyant force or buoyancy, children, you have the Archimedes Principle. In order to understand what is Archimedes Principle, let us study a simple activity. You all know now what is a spring balance. You all have seen in school lab as well. So whenever you hang any object to the spring balance, the spring present there expands or it gets elongated according to the weight of the object. So now we have imagine you have taken a spring balance and with the help of a thread we have tied a stone through the hook of the spring balance. So when you do so, for the weight of the stone, the spring gets elongated or expanded and it shows some reading on the scale there. So let us note down the reading. Next, just take the stone and try to immerse in a beaker containing water. What we observe here is, children, as and when you try to immerse the stone with the help of spring balance into the water, the reading in the spring balance goes on decreasing. It goes on decreasing. As and when you are lowering the height, means as you are trying to immerse more and more inside the stone what you are immersing, when you go more and more inside the surface of the water, the elongation of the spring decreases and hence also the reading of the spring balance goes on decreasing. Why does it happen? Means we all know, children, whenever you are trying to immerse any object inside the water, the upward thrust or upward force is exerted by the water on that object, but it is resulting in decreasing of the value of the spring balance, means its weight is going on reducing. Why does it happen? Means That answer was given by the scientist named Archimedes by his principle, and hence it is named as Archimedes Principle. So what does it state? We shall see now. So the statement has to be written as it is, children. When a body is fully or partially immersed in the water, it experiences an upward force that is equal to its weight. That is equal to its weight of the fluid displaced by it. Means, so now I will give you a bucket of water and a stone. When you throw the stone into the bucket filled with water, some part of water spills out. Some part of the water spills out. How much water has spilled out? Have you ever thought? How much ever the weight of the stone, that much water will be spilled out, children. That much water will spill out. That is what he is explaining here. When you try to immerse any object inside the water, what is happening here is that place where water was present inside the beaker, the water is pushed away now, and that space is occupied by the object which you are trying to immerse inside it. So, when you are trying to partially or fully immerse the any object inside the beaker containing water, what will happen is the upward force will be, or upward thrust will be acting upon by the body. Who is applying this upward thrust? Of course, the water. The water is trying to push it up, so that is the upward force. How much force is the water applying? Means that is equal to the weight of the object you are trying to immerse inside the water. That is what the Archimedes stated. So now let us read the statement. When a body is immersed fully or partially in a fluid, it experiences an upward force. It experiences an upward force that is equal to the weight of the object. Weight of the fluid displaced by it. I said no, how much ever fluid is displaced when you are trying to immerse the object, that much force will be exerted by the water. That is, the upward thrust will be acting. I said now, when you throw a stone, some water will be displaced. That how much water is displaced means it is equal to how much space it occupied, the object occupied in the surface of the water. And that is what he means by this, is equal to the weight of the fluid displaced by it. So Archimedes principle, and this is the principle of Archimedes. You have to remember this activity also. You may be asked, I have stated the Archimedes principle with the help of an activity. Means you should have to explain this activity, children. And what are its applications? It has very wide range of applications, children. So it is used in designing ships and submarines. You hope now you got the reason why the ships and the boats doesn't sink when floating, and it keeps floating. It is based on the Archimedes principle. So based on his principle, the ships were designed. And submarines also. Lactometer, you have heard of lactometer. It is the device which is used to check the purity of milk. So lactometer, which are used to determine the purity of sample of milk, and hydrometers used for determining the density of liquids are based on principle. What is a lactometer? You know. What is hydrometer? Means, just now we studied, no children, dirt is density. It is ratio of mass by volume is density. So in order to find the density of any object, this hydrometer, the device is used. The last topic we are left with in this lesson is the relative density. What is relative density? Just now we understood what is density. It is just the ratio of mass and was to the volume of any object. What is relative density? Means if you are talking with respect to density of two objects, then it is relative density. How? Density of water, density of oil. So ratio of density of water to that of oil gives you relative density. So with respect to any two objects, if you are talking about their densities, it is nothing but the relative density, children. So let us soon define, read what it is. As you know, the density of a substance is defined as the mass of unit. The density of a substance is defined as the mass of a unit volume. The unit density is kilogram per meter cube. Look here, we learn now, children, density is mass by volume. What is the unit of mass? Kg. What is the unit of volume? Meter cube or centimeter cube. So kg per meter cube becomes the unit of density. You can write it either way. Kg/m cube, m power plus 3, or kg m power minus 3 slash or minus 3. Anyone should be returned. The density of a substance under specific condition remains the same. Therefore, the density of a substance is one of its characteristic property. It is different for different substances. Of course, each object has its own density. It is, for example, the density of gold is 19,300 kg per meter cube, while that of water is 1000 kg per meter cube. The density of a given sample of a substance can help us to determine its purity. It is often convenient to express density of a substance in comparison with that of the water. The relative density of a substance is the ratio of its density to that of the water. So, relative density means, as I said you with respect to oil and water, children, if you are finding out the density of any substance with respect to density of water, then that ratio is called the relative density. You might have heard the story of Akbar and Birbal in your childhood. Once, Akbar Birbal Buddhivantana. Once the Birbal was given a task by his king Akbar. What he said was, he gave him the gold which was mixed with purity and asked him to find what is the density of gold, what is the weight of the gold, pure gold you calculate, he said. But he sat and thought for a long time, how can I find out? Either I should melt the gold so that the gold gets separate and the impurity I can separate, then measure the gold. But later he thought of this Archimedes Principle. What he did was, he just threw the gold mixed with impurity into the water. How much ever water got displaced, by that he found out the weight of the gold. One story is there, I am not that sure about the story. You can search, children, or you might have heard of this story. So during those days only the Archimedes Principle were known to those people. How interesting, no? So that is about the relative density. If you are measuring the density of any substance with respect to the density of water, that gives you the relative density. Since the relative density is a ratio of similar quantities, I said no, it is the unit of density is kg per meter cube, but when relative density we tell, it is just the ratio of any object to that of the water, means it has no unit. Why? Because both are same, no? So density of object kg per meter cube divided by density of water, if you write again kg per meter cube. So kg per meter cube will get cancelled. That is the reason relative density has no unit. It has no unit. You have one last example problem based on this concept of relative density. So relative density of silver is 10.8 and the density of water is 10 power 3 kg per meter cube. When they are given the relative density, they have not mentioned the unit, children, but when mentioning the density of water, they have given the unity. That you should concentrate. This is 10.7. So relative density of silver is 10.8 and density of water is 10 power 3 kg per meter cube. What is the density of silver? So density of silver is what? Density of silver is question mark now. We know the formula for relative density. So relative density is density of silver divided by density of water. Now we know what is relative density. It is 10.8 is equal to density of silver, we don't know. I will write it as it is, divided by density of water is 10 power 3 kg per meter cube. So what is density of silver, Andra? It is simply 10.8 into 10 power 3 kg per meter cube is the density of silver. Just cross multiply. relative density kottidare, density of silver we are finding out, density of what is given andre, density of silver is simply 10.8 into 10 power 3 kg per meter cube. That is how we find the relative density of any given object. It is very simple formula, simple concept as well. I will be sending in the worksheet more problems based on these concepts, children. Please practice it well. This completes the lesson gravitation. Up to this lesson you have for your coming SA1, and shortly I will be sending you the notes in the group. Please go through it and complete it. Till then, study well for your test. Take care.